Welcome everyone to this lecture on the inner join. There are several types of joins, and in this lecture we're going to go through what I think is the simplest join type, which is an inner join. And typically when students are learning about joins in SQL, they always start off with the inner join because it's the easiest to understand. First off, what actually is a join operation? Put simply, joins allow us to combine multiple tables together. Now the main reason for the different join types is to decide how to deal with information only present in one of the joined tables. So let's begin by imagining a very simple example. Let's say our company is holding a conference for people in the movie rental industry. So before the conference actually starts, we're going to have people register online beforehand. And the registration is simply just providing their name, and we'll keep track of people as they register. And then the actual day of the conference, they're going to come in and log in through an iPad with their name. So after the conference, we end up having these tables. So we have a registrations table as well as a logins table. The respective ID columns indicate what order they registered or logged in on site. So we can see in the registrations column we have Andrew who registered first, then Bob, then Charlie, then David. And then we have logins with Xavier, Andrew, Yolanda, and Bob. For the sake of simplicity, we're going to assume that in this little small universe, all the first names are unique. So there are not two Andrews, there's not two Bobs, every person has a unique name. Now to help you keep track of the different joins, since we're going to be using these example tables throughout this section of the course, keep in mind that the registration names, first letters, go A, B, C, D. And if you take a look at logins, the two outstanding ones that are not in the registrations are Xavier and Yolanda, basically implying that they forgot to register but still showed up the day of the conference. So what does an inner join do? An inner join will result with the set of records that match in both tables. So the situation we have right now is in the registrations we had Andrew, Bob, and Charlie and David register for the conference. However, the actual day of the conference when people were logging in, we only had Andrew and Bob show up that actually registered, and then Xavier and Yolanda, who forgot to register, they came in on site and then logged in. And keep in mind here that it looks like Charlie and David registered but didn't end up showing up to the conference to log in. So we have that discrepancy there of Xavier and Yolanda in the logins table and then Charlie and David in the registrations table. So where do we actually have a match in both tables? Well, we have Andrew and Bob. Andrew and Bob are the only ones that both registered and logged in the day of the conference. So an inner join is going to be able to join these tables together for records that are a match in both tables. So when we're talking about an inner join, we're only looking for the set of records that happen to be in both tables. And in this case, that would only be Andrew and Bob. So what's the actual syntax for this? Well, we can say select and then whatever columns you want, but in this case, we'll keep things simple by selecting all columns. And we say select all the columns from table A and then inner join with table B. And then we provide what we're actually matching on. So match on table A column is equal to table B dot column match. So what does that actually look like in practice? So if we color code this and think of the tables as Venn diagrams, and if you look up SQL joins on Google image search, you'll see a ton of Venn diagrams. So a lot of people like to think of it this way. If we see here that we're selecting from table A, inner joined on table B, where table A column match is equal to table B dot column match. So we're essentially saying grab table A and then grab table B, and because it's an inner join, only grab the rows that happen to be in both table A and table B. And we have to actually join these tables on a particular column, such as the name column that we saw in registrations and logins, because we know the names are unique over this small universe of people. There's only one Andrew, only one Bob, etc. Now, something to keep in mind, especially with an inner join, is notice that this Venn diagram essentially is only filled in the crossover middle. Essentially, stuff that can be found in both of these circles, table A and table B. Because of that, inner join is essentially symmetrical, which means if you select from table A and then inner join table B to look like this, select from table B, inner join on table A, you would get the same result. So getting from table A and then joining on table B is the same as getting from table B and then inner joining on table A. Keep in mind this is only true for an inner join in this particular case. So switching around the orders here, even switching around the column match order, doesn't really matter for an inner join because it's the same regardless, because this is a symmetrical Venn diagram. So let's actually work through this and what would actually happen in a more realistic situation with the example tables. Here we're going to say select all the columns from registrations, inner join logins. So that's essentially saying take registrations table and then perform an inner join with logins, seeing the rows that happen to be in both registrations and logins. And then we have to decide what column we're actually looking at in order to perform this inner join. And in this case, we'll do it on the name. We'll say on registrations.name, so it's the table name dot and then the column name is equal to the table name dot column name, so logins.name. And keep in mind, you could swap any of these orders around because it's an inner join, it's symmetrical. It doesn't really matter if we're saying select from registrations, inner join on logins, or select from logins, inner join on registrations. And you can also swap around that on equals sign to be something like on logins.name equals registrations name. Okay, so here we're just generally showing the syntax, and we're looking at that name column. So then we look at, well, where do we have a match in both tables? And that happens to be Andrew and Bob. And so we said select all the columns from these. So that includes the registration ID column as well as the login ID column. So we have these 4 columns, we have the matches, and we join them together to see this result. So this is selecting all the columns from the resulting of registration inner joined with logins on the name column. Okay, and that's it. That's an inner join. Again, an inner join is looking for matches that exist within both tables. And here we're saying select all the columns. Notice, because we said select all the columns, the name column happens to be duplicated or repeated twice because there's both a name in the registrations and the name in the logins. If you wanted to get rid of this duplication, what you can do is actually specify what columns you want. So here I'm saying select registration ID, logins.name, then login ID from registrations, inner join logins on registrations.name equals logins.name. So you might be wondering, why did I have to specify logins.name instead of just saying name? Well, the reason for that is because name existed in both tables. So we had both tables share a column name, which means if I'm selecting something after a join, I should specify what table I'm referring to in regards to the name column. And in this case, it doesn't really matter. I could have said registrations.name or logins.name, but I should be specifying because there's a duplicate name column. In my SQL query, I should be specifying what actual column I'm looking at. Because recall, here we had both the name column from registrations and the name column from logins. So if I only want one of those, because it's duplicated, I'll specify that I'm looking at logins.name column. Remember, again, that table order won't matter in an inner join. And also, if you see just join without the inner, PostgreSQL will treat it as an inner join. Now, I'd highly recommend that you always type out the full inner join, but some people, as they get really used to PostgreSQL, just use the shorthand of join, which defaults to inner join. Okay, let's go ahead and jump to pgadmin and work through a couple of examples. Okay, here we are in pgadmin. Now, if we come over here to schemas under public, under tables, we can see the various columns that are in the tables. So if we take a look at, for example, the customer table, we can expand the columns, and we can see we have the customer ID, and then the associated information with that, such as store ID, first name, last name, email, etc. And we can see in the payment table, we have the payments as well as a specific payment ID and then the customer ID. So what I want to begin exploring is if there was a way I could join the payment table with the customer table in order to get maybe the customer email associated with a specific payment. So for example, I can say, select everything from payments. We'll go ahead and run that. Let's put this on 2 lines together just for readability. So I run this and I can see I have a payment ID and then a customer ID, staff ID, rental ID, amount, etc. Let's go ahead and do the following. We'll say select everything from payment and we'll perform an inner join with the customer table. So this is essentially table A inner joined with table B. And since I'm doing an inner join, I'm only going to get back results where that particular customer happens to be both in the payment table and in the customer table. And now I have to decide what I'm actually going to join them on. So I have to join them on a column that is associated with both the payment table and the customer table. And I can see I have this customer ID column, which essentially uniquely identifies every single customer. So let's go ahead and join it on, and then we'll say payment.customer underscore ID equal to the customer table dot customer ID. And if we run this, we should get back a lot of columns. So we run this, and we can expand on this. And now you'll see I have the payment ID, customer ID, essentially all the information from the original payment table. But if I keep going further, now I see the repeated information based off customer ID, but now it's on the customer table. So I see the store ID, first name, last name, email, address, etc. All right, now let's see how we can select certain columns from each table. If I'm referring to a column that can only be found in one of the tables, then I don't need to specify what table it should come from. Luckily, PostgreSQL is smart enough to understand that if I refer to something such as select the payment ID column, since that's only found in the payment table, I don't need to actually clarify what table it should come from. However, if I'm referring to something like customer underscore ID, that can be found in both tables. So I should clarify what table I'm actually asking the customer ID from. And since I'm asking for payment ID, I should probably link it to the customer ID from the payment table. So I do this by saying payment dot, and then I ask for the customer ID. And then finally, let's go ahead and choose some column that is unique to the customer table. For example, their first name. So we'll simply say something like first underscore name, and let's go ahead and try that out. I'll put this from on a new line here. So I'm selecting the payment ID, which is unique to the payment table, payment.customer ID. Customer ID is not unique to either table, so I clarify what table I'm actually referring to for that column. And then we select first name. First name was unique to the customer table, so I don't need to say customer.firstname. Optionally, you can say customer.firstname and nothing will happen or nothing will change, but it's just easier to say just first name. So let's go ahead and run this and see the results. Notice now I get to see payment ID, customer ID, and first name. So this is the general syntax that we're using for inner join. Notice how the inner join is only going to join customers that are found in both payment and the customer table. Essentially what that means is by providing this inner join, I'm not going to see customers that have never created any sort of payment because I'm only looking for customer IDs that are found in both the payment table and the customer table because of this inner join. So again, general syntax, I select columns from a table, let's say table A, inner join on table B, and then on payment.customer ID equal to customer.customer ID. So table A, the identifying column equal to table B and the same identifying column. Keep in mind, this column could be called something else in the customer table. It could be maybe shortened to just C underscore ID, but as long as they're referring to the same thing, the customer ID, that's okay. Typically, in a well-designed database, these should have the same column name, but keep in mind sometimes the column name will be slightly different in one table than the other, so it's up to you as the SQL query developer to just make sure and double check that it's referring to the same thing. And as I mentioned before, for an inner join, technically these orders don't really matter. I could say from customer inner join with payment, and if I run this, I actually get back the exact same results. And depending on what version of SQL you're running, or PostgreSQL, they may be in a slightly different order. However, keep in mind those results should be exactly the same because we're only looking at the intersection of that Venn diagram, stuff that's both in table A and table B. So it doesn't really matter what order you're looking at it because that Venn diagram is symmetrical. Okay, that's it for the inner join. Again, this is pretty much the simplest join possible, just looking at rows that happen to be in both tables. Thanks, and I'll see you at the next lecture.